Okay, I'm going to try to replicate how to do paper and pencil dilation here on Schoology. So you've got a figure with a point of dilation. So let's change that to P. So on any hand created dilation you're going to have a couple of things. You're going to have a scale factor, you're going to have a dilation point, and you're going to have a pre-image. And you're going to need to draw lines. You'll draw lines of dilation from P through every point on the pre-image. E and D happen to both be on the same line. That's interesting. You're then going to need to measure. So I'm going to use a segment tool. So we're going to use a segment tool on GeoGebra to put a value on each of these segments from the point of dilation to the vertex on the pre-image. You're going to use a ruler to actually measure those distances. So you've gone through your polygon with your measuring tool and your straight edge. You've drawn lines from the dilation point through every vertex. You've measured the distance from the dilation point to every vertex. Now you need a scale factor. So for simplicity's sake, let's use a scale factor of 2. So I want to double the distance from P to the new point. In this case, it'll be P to B has a distance of 5.93. I need to double that to go from P to B prime. The easiest way for you to do that is to simply double 5.93 and then measure that out and put a new point, B prime. I'm going to use a segment with a given length. I'm going to create another segment, 5.93. And I'm going to drag that segment along my line, and then I'm going to rename that point A prime. That should be B prime. And same thing with A. I have a distance of 4.37. I'm going to use a segment with a given length to double that. 4.37 from A along the dilation line. And there's my A prime. I need a C prime. The distance between A and C is 6.17, so I'm going to double that by adding another 6.17 from C along the line of dilation. I'll call the new point C prime. Two more, 5.78 from E. So these are distances you will measure from the point of dilation to every point on the vertex. You'll multiply that distance by the scale factor. You'll measure out the new distance for your image points, E prime. One more, my distance to D is 8.94. Is that my distance to D or my distance to E? So I'm looking to go from dilation point to D. So that's segment P, 8.94, yes. Now I'm a little suspicious of this distance. So I'm going to drag it back to the dilation point and see if it matches. And it does. So along my line of dilation, I'm going to create new point D prime. Whoops. I don't want a caption, I actually want a new name. Okay, so I have my new image points. I can now connect them, A prime, B prime, C prime, and I should have a copy that's twice as large, D prime. I've moved everything twice as far from the point of dilation, so my second image should simply be a double of my first. What's interesting is these segments are parallel in each case. So segment A prime, B prime is parallel to segment AB. Segment AE is parallel to segment A prime, E prime. Let's see if we are fairly accurate. Let's dilate this figure from this point by a factor of 2. And it landed right on top of that. So if you're careful with your measurements and your pencil and paper lines and image points, you will get perfect copies. This is how an image looks when the point of dilation is off of the image. We'll take a look at 2 more cases. When the point of dilation is inside the image, it's kind of cool. You do the same thing. You're still going to draw lines from your dilation point through every vertex of your pre-image. Can you predict where your image is going to land? You've got to measure these segments along these lines of dilation. And let's do 2 things. Let's use a scale factor larger than the figure. So let's dilate this from this point by a factor of 1.5. And it lands outside the figure. And let's dilate this figure through this dilation point by 1/2. And it lands inside the figure. Now, when the dilation point is on the figure, one of your image points is the point of dilation. So let's try that with E. Let's try that with F. We will dilate this figure from point F, dilate this figure from point F. Oh, let's do a factor of let's do 1.6. So notice that there are still dilation lines from the point of dilation through every point on the pre-image, and your image points land on those lines just like they do in every other case. Okay, you're going to try this with paper and pencil tonight.